Hi everyone, welcome along to lecture number 8 of our Advanced Manufacturing Technology module. And today we're going to study the machining and the tool paths as applied within Alphacam. Now last week we finished off our learning about the creation of geometry and drawing shapes, and today we want to start machining them because ultimately that's what we want to use this software Alphacam for. So today we're going to draw some various solids, some various geometries, and actually process them. So we're going to use some of the shapes that we completed previously, but within Alphacam we're going to convert those into 3D solid blocks and then apply this blue graphic that you can see here that represents the tool cutter. We'll apply the tool cutter and the tool paths to those geometries. Now, so launching the software, I'm just going to begin very quickly. It's only going to take a moment by drawing some of the shapes that we did previously because I want to machine them today. So I'm going to start off with a simple little bracket that we did previously. So I'm going to draw a line horizontally from 0 tab 0 to 90 tab 0. And I'm going to call up, first of all, I'll turn off that construction. I'm going to call up the geometry tab again. I'm going to go to circle and I'm going to go to center and radius. The radius will be 10. Let's zoom in a little there. And I want to drop a copy of that to the left. So let's turn on the auto snap, drop a copy to the left, and press OK, drop a copy to the right. Let's put in a radius now of 48, or sorry, it's not 48, it's actually 25. I'm looking at the wrong drawing, 25. Let's put a copy there, and another copy there. And we're nearly there then. Let's go to a different type of circle, a tangent radius, or a tangent with known radius. So if I select that, the radius is going to be 60 and I want it to be tangential to two arcs. Select this arc at the top, that arc at the top. I'm happy with the blue highlighted circle, so right click, accept highlighted circle. And let's now put that one in at the bottom as well. So it's the same two arcs. Click the bottom, right click, accept highlighted circle. And let's go to edit, trim, all, and finish. And simply click away the pieces you don't want anymore. And press escape. So I now want to start the process of machining this. I need to cut that shape out of a block. The first thing that you should do is press Ctrl G and you'll see there's too many ghost tools. Now I've mentioned ghost tools a lot and they'll be more important today. Ghost tools show, if I press Ctrl G again, where the cutter will engage the workpiece and the direction it will travel. But obviously this outer profile does not require the 5 or 6 ghost tools that are there. I just need a single ghost tool. That's why we join, all, and finish. And that's more like it. I just need a single pass of a cutter to cut out the outside profile and a single pass for each of the inside circles there. By the way, that little white cross that you see there, that's just a break. So view, display options, show breaks. I always like to see those, but you don't have to have those on. I'm going to temporarily press Ctrl G just to turn off the ghost tool. And what I can do now is go to the geometry tab and let's draw a piece of material, a piece of timber in this case, that is going to be the blank that this part starts off with. Now my 0 is actually there, so what I'm going to do is I'm going to pick some random point for now. Let's say minus 30 tab minus 30. And let's set that to a value of 120, 30. So 120, tab, 30, enter. And it's much better, rather than having minus values, if I can have this block, this square, starting at the origin. So I'm going to go to Edit, Move. I'll select all and go Finish. The base point, you can either pick it up or you can type in the coordinate. I'm going to pick it up here. And I'm going to drop that onto the origin, or simply type in 0, tab 0, enter. And at least now, this artifact, this solid, is going to sync up with the 0, 0, the origin of my CNC and of the Alphacam model space here. So that rectangle represents the block, the 3D block that I want to put up onto the CNC and machine this curved bracket from. So let's move over to a 3D view by going to View and ISO. Or depending on how your computer is set up, you can also activate isometric from down here, or in fact you can press all the other different views either. I want to set a material thickness. I want to make this rectangle a block of material. So let's go to 3D, Set Materials. it prompts you to pick a geometry or solid. So I deliberately drew this rectangle to represent the outer boundary of the block of timber, of the blank. So in a moment you'll see that rectangle will disappear. So I'll click that rectangle, and it asks me to set the material top Z. So far we've been dealing with the X and Y directions. So the X was the left and right coordinate, the Y was the up and down coordinate on our screen, but the Z is the third dimension. The Z is the thickness of the material. So when it asks me to set the material top Z, that is the top of the material. Now it depends on the way the company, the way the college, the way the CNC is configured, but in our case we're going to set the top of the timber, the top of that piece of material, to 0. And then any value below that will be a minus value. So let's say I want this block to be made from 20 mil material. So let's set the top to be 0 and the bottom to be minus 20. Now if I press OK, what that does is it sets a block, this grey block, and just seeing as I'm here, I better explain the rotate command actually. You just do a regular left click and drag, and it will rotate the environment for you. But you can see there that the block has been created based on the rectangle. The rectangle has now disappeared, leaving the geometry inside, and the Z value is 20. Or sorry, minus 20. I know it's minus 20 because this little triad, it sits on the top surface. That is 0. The origin is 0, 0. So anything going below that is a negative Z value. And that's just the way we have our machine configured. So every value above 0 is not going to be cut, and everything below 0 is liable to be cut, to be processed. So it's now time to go and try to machine this out, and I'm going to leave myself in a 3D view for the time being. So what I'm going to do is go to Machine. The Machine tab is where a lot of the machining options will be, and you'll see there's a lot of them grayed out for the minute. What you could do at this point actually is you could go to Home, select Post, and that's kind of like selecting your printer. So you can go and see which of the CNC machines that are currently loaded here suit you. I'm just going to pick the wiki here at the bottom, and that now loads that machine. It loads the post processor or the machine into this file. So it knows now what the capabilities of the machine are. You don't always have to do that. Let's get back on track. Let's go to Machine, and what I want to do is apply a cutter to tell it to run along this green line. So first of all, before I can do too much, I have to go and select a tool. So if you go to Select Tool, this is the current library of tools that's loaded into my version of Alphacam. And if you click the various tools there, you can see a preview of them appears to the left. Now you have to be careful. Just because the tool is here in the library of Alphacam does not necessarily mean that you have that physical bit of metal, that physical cutter or tool in the machine hall. Also, just because the cutter has a particular shape here, for instance the drill, the 10mm drill, you mightn't actually have a 10mm drill, or it might be a slightly different version, or it might be worn. So you have to constantly check and recheck that your digital database of tools here is the same as your physical tool catalog. For now, I'm going to go to flat 10mm cutter, and in time we'll create our own tools, but you can see that that's tool number 3. It's a flat cutter, diameter 10, and so on. So what you do is you select flat 10mm, you double click it in fact. When you double click it, you get a preview, and this preview is handy because in a minute I'm going to want to use that cutter to cut out or machine out the inside of that hole, and I can very easily see now that that will fit. But if this was too big, for instance, if I press Escape and if I go to a 20mm cutter, you can see it's actually going to work in this case, but it might actually be a little bit too big. So if you double click flat 10, what I did a minute ago was I pressed Escape to abort to get rid of that, or what you can do is just press Enter to accept the tool. Now nothing really happens in the graphic window, but now an awful lot more of these tools, these commands have become visible. You tend to not be able to do a lot until you activate a tool. Now just to help explain my point, I'm going to go to Select Tool again. I'm going to call up flat 10mm cutter, and what we have there is a green geometry, and I want this cutter to follow along that green geometry and process the shape as I do it. But there's 3 different options. I can send the cutter along the center of the line like that, so the center of this cutter, this router cutter essentially, will follow that green line. Or I can tell it to always process the material outside the shape, or I can tell it to always process the material inside the shape. In the same way, these two little holes, I can tell the cutter to remove all the material from the inside, I can tell it to run along the outside or along the center. I'll tap escape to abort that. What I'm explaining there is tool directions. So if I get over to tool directions, and while I'm at it, I'm going to go Control G. I better actually press Control G first of all. Control G to turn on the ghost tools. Now turn on tool directions. What I can see there is that that arrow, that ghost tool, is centered on the green line, on the geometry. No matter how far I zoom in there, that ghost tool is on the green line. I don't want my router cutter to cut along the center of that, because if I do that, the 10mm router cutter will remove 5mm material one side and 5mm material from the inside. I want to retain and protect that green geometry. Now there are two things. There's open geometries and closed geometries. An open geometry, if I just go back for a second, an open geometry is something like this arc. It does not enclose area, or a line, or a series of lines that do not enclose area. They are open geometries. Closed geometries are things like rectangles or things like circles that do enclose geometry. So when I go to Machine and Tool Directions, I don't have any open geometries here. I've got closed geometries. I've got closed loops. I'm not going to change this for now, but you can change the direction of the toolpath. You can change whether it goes in a clockwise or an anti-clockwise direction. What I do want to change now is the side of the geometry that those ghost tools rest. So I want to select outside, and I'm about to select this outer geometry, and as I click, you'll see it's very subtle, but you'll see that white ghost tool will jump to the outside. So I'm about to click now, and it jumps to the outside a little. Here I want to protect this circle, so I want this ghost tool to actually jump to the inside. I want to do all the machining on the inside of that circle. So let's go to inside, and as I select that circle, that ghost tool jumps inside, and as I select this circle, it jumps inside. So press close. So that's the procedure so far. You draw the geometry, you join it or make sure that it's joined. You then go and select a tool to make sure that you have the proper cutter loaded in. And finally, what I've just done there is you set the tool directions. So we're now ready to actually apply a bit of machining. And you can apply the machining either here in the 3D ISO view, or you can go to View and do it in the XY view. People have different preferences. I personally think it's a little easier to visualize it when you see the 3D graphic here. And by the way, just in case I haven't explained this already, if you are in the View tab, you can access the Pan command, which will allow you to pan the model around the place, or the Zoom or the Zoom All, but I find it easier to use the scroll on the mouse wheel to zoom in and out, a regular left click and drag to rotate the model, and your mouse wheel button when depressed allows you to pan. Another couple of display options here, I tend not to change them. You can always change your background color if for some reason that blue is a little hard to see, and there's other display options in here you can also set as well. So if you want a white plain background, to get in there and change the background color. Getting back on track, if I go to Machine, I've set the tool direction, I've set the tool and actually select the tool. What I want to do now is go to Rough or Finish Cut. And the reason it's called Rough or Finish Cut is typically when you're processing things like that, you will rough out a lot of the bulk of the material first of all, and then you'll go back on with a more precise, a more delicate cut. So even though I see Rough or Finish Cut, that button could just as easily be called Apply Tooling. So go Rough or Finish Cut, and you have a few options to deal with here. For now, we're going to leave the first window, the first panel, the first tab here alone. It's a vertical drilling process. I certainly don't want to drill at an angle. I just want to drill or machine straight down for now. Also, if I select all geometries, it'll automatically apply the tooling at the end to all geometries. And in this case, that'll work, but for now, I want to go Selected. So let's move on to General. The tool number is dependent on the machine. You pick the tool number from the catalogue, or it depends on where the tool is in your machine. Your machine might have a carousel that can hold 20 tools, or it might just have 2 tools, and you'll have a number on each tool. If you hadn't yet changed the tool, you can select change tool here. For instance, flat 10 mil. That's what I have selected. If for some reason you want to change it, you can change it here. The roll around corners and the straight and the loop corners, we'll talk about that in a moment, but that's just going to change how the machine cutter actually goes around corners, and you'll get a different finish or different quality finish depending on those settings. Levels and cuts. I'm not going to cover all of the options here in this very first exposure to machining, but this is the most important one. So before I enter that, I just want to move over to a graphic and explain what I mean by these Z levels, these settings. Now this is a very simple graphic to try and explain my point. Here at the bottom we've got a representation of a clamp. We'll talk about clamping and work holding in more detail. You typically don't have a vise like this. But what we have is a block of timber in the clamp or in the vise or in the pods, or it's held in some way on the machine bed. So what we have at the very top there is the work surface, and that's what we've set to 0. That's the absolute top of the material. No bit of timber is above that surface. A safe rapid level, this represents the cutter, this rectangle up here. A safe rapid level represents the height that the cutter can safely move around without fouling or bumping in or breaking the work material. The rapid down to then is a level that the machine cutter, when moved into position, will move quickly down as far as before it then slowly starts to engage the workpiece. Your cutter may be 100 or 200 mil above the workpiece, and you don't want that to move painfully slow down towards the workpiece. You do want it to engage the workpiece slowly and carefully, but the safe rapid level is where the machine just moves out quickly to the left in this case. The rapid down to level is where the machine will move down to quickly before it starts taking account of the feeds and the speeds and the rotation speeds, and then slowly engage in the workpiece. A moment ago I discussed the XY corners. If you have roll around corner, this is a plan view of the cutter. It will roll around the corner and it will never leave contact with the workpiece, producing that square edge. A straight cut means it's going to go straight out to the right like this and straight down, but technically it does leave the cutter does leave the corner of the workpiece. And a loop then means that it's actually going to move out to the right, come around in a loop and move straight down. The advantage of that is that some materials might get a slightly better finish if the machine doesn't suddenly move over and then stop for a second and start moving down. This loop allows the cutter to continually keep moving at the same speed and not cause any little bumps or notches in the corner of the material. So that'll all be a bit more obvious when we start actually doing some machining. So back in Alphacam then, we should now be in a position to understand these. The safe rapid level is going to be something along the lines of, let's say, 40 mil. There's no right figure to put in there, but there certainly are wrong figures. If I put in a minus value, that means the computer in Alphacam will feel as if it can move the cutter anywhere below 0, and it could potentially break the cutter or damage the workpiece. So you want the safe rapid level to be a distance above the highest point of your material. Remember, our material is at 0, so somewhere above 0 is just a positive value. The rapid down to then is usually a value somewhere between the safe rapid level and the material top. So I'm going to set the rapid down to about 5 or 6 mil. The material top we've already set to be 0. That's where the material starts. And the final depth, it depends on whether you want to cut all the way through or not. Our material is 20. For now I'm going to assume that I want to cut all the way through to the bottom, so I'll go 20. And when we talk about work holding, you may sometimes only want to go down as far as 18 and not actually cut all the way through, and you'll finish off and break it out later with a router or a jigsaw or something like that. If you hold the work differently, you may very well want to put the router cutter all the way through and out the bottom. But for now, I'm just going to put in a final depth of 20. Now, number of cuts is the number of number of passes it's going to take to cut that out. So if I leave number of cuts set to 1, it means it's going to remove the 20 mil of material in one pass. Now that's a little bit too much. If you're machining out hardwood with a 10 mil cutter, typically you might go 3 or 4 passes. And certainly if you have a larger cutter or even a more delicate cutter, you'd want to change the number of cuts there as well. As soon as you go above a single cut, 3 in this case, it prompts you to put in the depth of cut. Now if I leave it at equal, then it's fine. It just puts in an even cut dividing 20 by 3 each time. But certain materials will require a very delicate cut, maybe just a millimetre or two for the first cut and a millimetre or two for the last cut. But I'm going to leave them at equal. So to summarise, my cutter is never going to go anywhere below 40 mil when moving into position. When it moves into position, then it's going to go quickly down as far as a height 5 mil above the work surface. The work surface or the material top is 0, and ultimately my cutter is going to cut down as far as 20. And I'm going to cut down as far as 20 in 3 even passes. Machining, I didn't mean to make that mistake, but it says rapid down to is below first cut. It just goes to show you that you could potentially make an error, but Alphacam is very good at prompting you. The mistake I made was this. Obviously my final depth isn't 20, my final depth is minus 20. So a little bit careless. Now if you were to make that machine in real life by programming the machine, you could potentially ruin the cutter or even ruin the tool head, which is very expensive. But Alphacam is the place to make your mistakes, it's the place to process it. And even if it didn't throw me up the warning there a minute ago, I would very quickly have seen the error when it goes to process in a minute. So make sure it's minus 20. Moving on to machining data then, I'm not going to talk about much of this yet in this very first exposure to machining, but we'll come back to there. Lead in, lead out allows you to start the cutter away from the workpiece and then have it engage gently with the edge of the workpiece. We'll worry about that next time as well. And tool data as well, that is already preloaded. So whoever made this tool or created this tool in Alphacam's library set up things like the speeds, the down feeds and the cut feeds and all that, but we are not going to worry about that in this case. The main thing I want you to kind of learn and practice in this session is the levels and cuts. They're the most important ones. So I'm going to press OK. And when you press OK, some people feel as if it has failed at this point because they're expecting the machining to be applied. Not the case. If you look down here, it says rough or finish, select geometries. I could actually press all in this case, but instead I'm going to press this outer green edge there, this inner circle, and that inner circle. And when all are selected, if I press finish, you'll see now these new blue lines. We haven't seen these before. So far we just have these pinky purple constructions, green geometries, but now we have blue tool paths. And looking at those tool paths, you can very clearly see where the cutter is going to start and where it's going to go. For instance, I've got 3 layers of those paths. That shows me that it's going to actually process this in 3 goes. If I look at it from above by going to View, XY, I can see that the blue line represents the very center of the cutter. So the blue line is inside those circles, but it's actually outside that kind of figure 8 link shape. Let's now go to ISO, and to see how this works, you can go to View, and be very careful here. There's a button that says Simulation, and there's one that says Solid Simulation. If I press Simulation, it just moves the cutter, but it doesn't really give me a good verification of what it looks like. So I'm going to press the X, stop on that first of all, and press the X to get rid of that. I want to go to Solid Simulation. So now it reverts the block to just a blank, and over here I can press play, and I can change the speed by dragging this bar, and you can see I'll go a little faster. And what it does is it machines out the 3 holes in 3 different steps, and it's going to machine out that outer profile in 3 different steps as well. And at this point, if there were any errors, or if the machine suddenly took the notion to go straight through the material and plow out a big groove out of it, in reality that would break the piece or the tool holder or the CNC or the cutter, but here, digitally, it's not going to cause any trouble at all. It's a very good way to visually verify that you have coded and programmed the machine correctly. So again, if I press play there, it runs through it. You can run through it very, very quickly. You can change various transparencies of solids if you wish, or of the tools. But for now, just know as well that if you want to get back to editing, that solid simulation won't go away unless you get over here and press this icon, Close Simulation. Or indeed, you could press this X to turn off the panel there as well. Now, I'm aware there might be a lot to take in there, so we're going to do another few examples. What I'd like you to do is try to have a go at this one yourself. Either open up the file that you've saved previously or draw this again. It should only take a couple of seconds. So try to draw this, try to create the solid and machine it out. So please pause the video and have a go at that. And if you want the solution, then just I'll draw it now in a moment for you. So you could draw this in a brand new empty Alphacam file, but I'm going to choose to do it here in the same file. So let's now go to View and XY, just so we're looking down like that. And I'm going to go to Geometry, turn on Construction, and I'll start up here somewhere. So I'm going to start at about, say, 0, tab 150, and I need to move over 100, so that's then going to be 100, tab 150. That's my construction line. Turn off Construction, go to Circle, and I need a circle radius 15 to the right and a circle radius 10 to the left. And while I'm at it, I need another circle radius 48 snapped onto the left and a circle radius 85, okay, snapped onto the right. And what I'm going to do now is join the two curves there as well. So if I go and select a line, you'll remember from the time we actually did this, I don't want it to snap onto the vertical top, vertex of the circles. I want it to be a tangent. So get down here and select the tangent snap and select that button there. And then turn on tangent again, select that curve there. Turn on another line command and do the same at the bottom. So go to tangent and select the bottom of that circle, tangent, select the bottom of that circle. Let's now trim out the excess. So Edit, Trim, All, Finish. And just trim away the bits we don't need. Tap Escape. So what I'm going to do is just move that little, actually, it's a little bit encroaching on that. So I'm going to go to Move, and I'm going to select the circles, the lines. I didn't press All because I don't want the original block to move as well. And I'm going to press Finish. I'll pick it up by its center there, and let's say I want to move that center to, we'll give it a precise point. So let's say 30, tab 250. I need to join it obviously because I can see lots of ghost tools. So let's go to Join and draw a box around all of that and press Finish. And I can see, check, I've got 3 ghost tools. It's exactly what I want. This time I'm going to draw a rectangle around it again, but I'm not going to actually use parameters. I'll just kind of guess it. And now I can go to a 3D view, so View, ISO. Let's go to 3D, Set Materials. I'm going to select the rectangle. The top is 0, the bottom this time, let's say it's just 10, minus 10, and press OK. I want to go to Machine, Tool Directions, go inside and select that circle and that circle to bring the cutters inside. Then select outside and click this outer profile to send the ghost tool outside and press close. Then go to select tool and make sure I have the correct tool. In this case, flat 10mm will work great. So double click that. Just verify that it looks okay. It does, and press enter to approve it. And then finally, rough or finish. I'll move straight to the levels and cuts. Say for rapid level is fine at 40. Rapid down to is fine at 5. Material top is still 0. The final depth in this case is minus 10 because that's what my material is. Minus 10, I probably would take out 3 passes, but let's just put in 2 passes for now. And then press OK. And I'm going to select the outer and the inner profiles, then press finish, and now I can see the process. Now the reason I did both processes here in the one Alphacam file is because you can see over here, the blue lines show where the cutter is going to move. And when it's finished here, it's actually going to move over here and then move over and process my second component. So if I go to View, Solid Simulation and press Play, once it cuts out those first ones, I'm going to slow it down now. It'll then move over and start processing the second one. Now the reason I selected this one is, in this case, excuse me, it does actually cut out the middle, but it left a little piece, a little kind of piece that'll fall away afterwards. Because the cutter wasn't big enough, like it was on the left here, to remove all the material inside, it leaves that little piece there. And there's ways around that that we'll explore in future as well. So for this session, if you can get to the stage where you can draw both of those geometries and apply that simple bit of machining to them, then that'll be enough for this session. And next week, we'll do some slightly more advanced machining.